Hey everyone, hope y'all doing well. Welcome to the first episode of the Ethernaut series. Ethernaut is a series of capture the flag style smart contract security challenges, whereby each level contains one or more vulnerable contracts. The goal of each level is for us to exploit such vulnerabilities, causing undesirable effects. I highly recommend going through this series. Not only will you gain a deeper understanding and appreciation for the EVM, but also a more intuitive grasp of various attack vectors common across multiple smart contract patterns. Now, without further ado, let's get it. In this video, we will be going through level 0, which is essentially the tutorial for Ethernaut, as well as level 1, Fallback. So let's go through the instructions of level 0 sequentially. First of all, we need MetaMask, which we already have right here. Next, let's open up the browser's console. On a Mac, the shortcut is Command-Option-I, really comes in handy. Next, we should note that we can call the help function in the console, which will give us a list of some very useful functions which we will be needing during the course of gameplay. It is also important to note that underneath Ethernaut, we will be interacting with Truffle contracts, so we can take a look at the relevant syntax from Truffle, from the Truffle documentation where necessary. Before this video, I have already obtained some Rinkeby ETH from this Chainlink Faucet. Highly recommend this. So now, let's just get a new instance of the contract. While we wait, perhaps we could try running one of these helper functions so we can actually see our Rinkeby ETH. Instance address, very cool. So, what do we need to do for this level? Let's look into the level's info method. So, let's type await contract.info, call the function. You will find what you need in info1. Very cryptic, very cool. Await contract.info1. Try info2, but with hello as a parameter. So let's just pass that in. Await contract.info2 with hello as a string as a parameter. The property info num holds the number of the next info method to call. So that is yet another function that we should call. The next info method. The number of the next info method. So we see 42 here. Presumably that means we should be calling contract.info 42. The method name is the name of the next method. So let's just do that. The method name. The method name is method 7123949. All right. Let's see what that gives us. If you know the password, submit it to authenticate. So let's take a look at the contract's ABI. Contract.ABI. So ABI is short for application binary interface. We can see what public methods we can actually call. So here we can see that there is a method called password of state mutability view, which means it is very likely that the password that we want will actually be in password. The password is Ethernaut 0, so we should submit the password to authenticate. Authenticate. So await contract.authenticate. Submit the password, which is a string of Ethernaut 0. Confirm the MetaMask transaction, just wait for it to be approved and mined. Right, so our transaction has been mined. I believe we can just submit the level instance back to the Ethernaut main contract. And just like that, level 0 should be complete. This will take a while. Okay, we're done with that. Let's go on to the next level then. So here we're at level 1 of Ethernaut, which is Fallback. Let's get a fresh instance of the contract. So the goal of this level is for us to claim ownership of the contract and to reduce its balance to 0. So let's check out the actual contract itself. There is a public variable called owner, which is initially set to message.sender in the instantialization of the contract. We can check out what owner is currently set to via await contract.owner, which is this address, which is equivalent to the level address. We should also note that there is a modifier called onlyOwner, which is quite a common modifier across various smart contracts. This modifier is relevant in the function withdraw right here. Essentially what this does is that if withdraw is called by an account, an externally owned account, or a smart contract, the address of which is not equal to the owner variable, then the call to withdraw will fail. So how do we become the owner of the contract? What can we possibly call? So first of all, we can see that in contribute, there is actually a potential way for us to set ourselves as the owner of the contract. However, there is a conditional that has to be passed. In this predicate, the amount of contributions we have has to be greater than the contributions of the current owner. The contributions of the current owner is set to 1,000. We can actually check that out right here, contract.contributions, using this address right here. Let's format that into a string. Right, we definitely do not have that amount. We can also see that right here in receive, we can also potentially set ourselves as the owner of this contract. However, another check has to be passed. The message.value of our call has to be greater than 0, and the contributions of message.sender also has to be greater than 0. Currently, I assume that our contributions is equal to 0. We can check that out right here. So pass in player as a parameter, format that. Zero, correct. How do we increment our contributions then? Via the contribute function, evidently. There's a check right here, requires that the message.value has to be less than 0.001 ether. After the check, the contributions of message.sender will be incremented by message.value. Okay. So let's try calling contribute with a value, meaning we will be sending ether to this payable function. In order to do that, let's check out the Truffle documentation. The relevant part is right here. We can check out this example. So here we can see that within the curly brackets, we can specify some transaction parameters. For example, we can specify from to gas price, value, data, and nonce. This object is a special object that can always be passed as the last parameter to a function that allow us to specify details about the transaction. This is perfect. Then what we should do is to call contribute. So await contract dot contribute dot send transaction from player to the contract.address, and the value of which should be two-way, as in a string 0.0001. So long as the value of the function call, the value of the transaction is less than 0.001 ETH as specified by this line, we should be good to go. The function two-way can actually be seen here in the help function, through the help function, which is one of the utilities available to us, which converts Ether units two-way. So let's just send this transaction. Once this is sent, we can check whether or not our contributions is greater than 0. If it is, we can pay a little bit more Ether, trigger the receive function, and we will then become the owner of the contract, presumably. Here, let's check our contributions. So player dot then x to string. Yep, that is greater than 0, which means we can now trigger receive. For this part, we will use send transaction, which is one of the utilities available to us. Send transaction from, this is the same as the Truffle syntax, so from player to contract.address, value of which, let's do this again, two-way 0.0001. Okay, let's just send that. Next thing we should do, presumably once this transaction is mined, we should be the owner of the contract. Let's see if we actually are. Await contract.owner. Let's wait for the transaction to be mined before calling it. Cool, now we can call it. This is the owner of the contract now. Let's check out our player address. This is the same, so we are now the owner of the contract. So the first step of beating this level has been achieved. Next, we need to reduce this balance to 0. As during our previous actions, we have actually seeded this contract with some amount of Ether. So now that we are the owner of the contract, we can call the withdraw function. So we will be transferred the entire balance of the current contract once we call the withdraw function. Let's just do that. Cool, we can check the balance of this contract via get balance, which is yet another utility available to us in the console. You can see it here. Get balance of the contract. Throw in and await. 0. Fantastic. Now let's try to submit this instance and see if we have beaten this level. So that concludes level 0 and level 1 of Ethernaut. If you have any questions, feel free to leave a comment. I'll be sure to reply. Stay tuned for more Ethernaut content.